Have you ever stopped to think about something so simple, yet so intriguing? Like what would happen if every single person on Earth jumped at the exact same time? It might sound like a trivial, almost comical thought experiment, but believe it or not, the question raises some fascinating insights into the interaction between humans and the planet we live on. In this video, we will explore the numbers, the physics, and the outcome of such an event, using some straightforward calculations and scientific reasoning. And no, we're not just talking about jumping out of bed or hopping over puddles. We're talking about every single person on the planet synchronized in one big leap. So what would happen? Would the Earth shake, tilt, or even wobble a bit from the sheer force of 8 billion people jumping at the same moment? The answer might surprise you. But first, let's break it down in a way that makes sense. The numbers behind the jump. Before we even get to the science, let's consider the logistics of the situation. There are about 8.01 billion people living on Earth today, and it's safe to assume that the vast majority of them can jump. Of course, we should account for certain groups like babies, elderly individuals, and people with disabilities, who may not participate in this massive leap. So, let's assume that 90% of the world's population can, in theory, jump. That brings us to roughly 7.2 billion people who could potentially be part of this synchronized jump. Let's also assume that these individuals, on average, would be awake for about 16 hours of the day. This means we can estimate that during a 24-hour period, roughly 17 million people will jump at the same time, on average. Now, considering the sheer weight of each person, say, about 60 kilograms, 132 pounds, the total weight of these jumpers adds up quickly. In fact, the combined weight of just 17 million people jumping at once amounts to a staggering 1.02 million tons, 2.24 billion pounds. Yet, despite all this mass, nothing happens to the Earth. The ground doesn't shake, the Earth doesn't tilt. Essentially, life goes on as usual. The mass of the Earth versus the mass of humans. So, why is it that despite all these people jumping at once, the Earth doesn't seem to notice? To answer this, we have to compare the mass of humanity with the mass of our planet. The mass of the Earth is a mind-boggling 5.972 times 10 to the power of 24 kg, 5.976 sextillion kilograms. To put this in perspective, this is 13 septillion 176 sextillion pounds, which is an astronomical number far beyond anything we can truly grasp. Now, what about the mass of all humans on Earth? Taking an average weight of 55 kilograms per person, we arrive at a total human mass of around 440.78 billion kilograms, or approximately 971 billion pounds. When we compare that to the mass of Earth, it's almost laughable. In fact, the combined weight of every human on Earth is a tiny fraction, 0.00000000073783147366768563776376364% of the mass of the planet. It's like a grain of sand compared to a mountain. Or more accurately, it's like a needle in a haystack. How big is the force of a collective jump? To understand this better, let's think about the force exerted by all these people jumping at the same time. The force of gravity on Earth pulls every individual toward the ground with a certain amount of strength, and it is this force that prevents us from floating away into space. When a person jumps, they exert an upward force against gravity. However, even if everyone on Earth were to jump simultaneously, the force they generate would be insignificant compared to the gravitational pull of the planet. This brings us to the key insight. The force of all humans jumping at the same time would be negligible in comparison to the Earth's gravitational force. The planet is simply too massive for any force we generate to have any noticeable effect. The Earth would continue on its course without even a blip. Real-world analogies. Could anything similar happen? Let's consider some real-world events where a large number of people moved simultaneously, say, millions of people at a concert or a stadium. While it's true that large crowds can create vibrations, even a stadium filled to capacity is still not enough to shake the planet. The same applies to the hypothetical mass leap we're discussing. Another interesting analogy involves earthquakes. When an earthquake occurs, it's because a huge amount of energy is released from the movement of tectonic plates. which are incredibly heavy and are shifting beneath the Earth's crust. The combined force of 8 billion people jumping simultaneously just cannot compare to the power of natural geological events. In fact, the force of a large earthquake can exceed the combined force of billions of humans by orders of magnitude. The conclusion: why jumping won't affect the Earth. Now, back to our original question. What would happen if everyone on Earth jumped at the same time? The short answer is absolutely nothing. The gravitational force of the Earth is so immense, and the combined weight of humanity is so tiny in comparison, that even the collective jump of 8 billion people would have no measurable impact on the planet. But let's not end there. This question raises some interesting thoughts about how interconnected we are with the world around us. The sheer scale of the Earth compared to our human experience is humbling. We often think of ourselves as the dominant force on this planet, but when you consider the scale of the Earth, the universe, or even our solar system, it becomes clear just how small we are in the grand scheme of things. A thoughtful reflection: what does this teach us? So, what can we take away from this? First, it reminds us of how fragile and interconnected everything is. Our actions, while meaningful to us, are often insignificant on a larger scale. However, this does not diminish our role as caretakers of this planet. While jumping in unison may not have any real effect on the Earth, the choices we make every day, such as how we treat the environment, how we work together, and how we care for each other, can have a profound impact. Furthermore, the idea of everyone jumping at once serves as a great metaphor for unity and collective action. It illustrates how the combined efforts of many people, while seemingly small on their own, can create a massive, positive impact if focused in the right direction. Final thoughts: it's about more than just jumping. In the end, the idea of everyone jumping at the same time serves more as a fun thought experiment than a realistic event. However, it underscores an important lesson. The forces of nature are much bigger and more powerful than anything we can muster as individuals. Whether it's the Earth's gravitational pull, the vastness of the cosmos, or the power of collective action, we should always keep in mind the enormity of the world around us. So, next time you jump, just remember that you're part of something much bigger than yourself. One small action among billions. The Earth may not feel it, but together, we can still make waves.